This is 2014 FRQ number 1 in the calculator portion. All right, grass clippings are placed in a bin where they decompose. For t between 0 and 30, the amount of grass clippings remaining in the bin is modeled by A of t, where A of t is measured in pounds and t is measured in days. Part A, find the average rate of change of A of t over the interval between 0 and 30, indicate units of measure. Average rate of change is slope. So what we need to do is find A of 30, that's our y1, and A of 0, that's our y2, or vice versa. So A of 30, A of 0, we get 6.687 times 0.931 to the 30th power, 6.687 times 0.931 to the 0 power. This one's just 6.687. This one, on the other hand, we will need a calculator. So let's see what the calculator says. 6.687 parentheses 0.931 to the 30th power. We get 0.783. All right, so y2 minus y1 over x2 minus x1. So 0.783 minus 6.687 equals negative 5.9 divided by 30. That gives me negative 0.196197 pounds per day. So that is the average rate of change over the interval. Okay. Part B, find the value of A prime of 15 using correct units. Interpret the meaning of the value in the context of the problem. So let's find A prime of t first. A prime of t equals 6.687. That's our coefficient. Something to the t power, our formula says that's natural log of the base, 0.931, and then the original function, 0.931 to the t. So that's our A prime. Plugging in 15, t equals 15, 6.687, natural log of 0.931, 0.931 to the 15th power. Oh, that's a long one. All right. 6.687, natural log 0.931, parentheses 0.931 to the 15th power. That gives us negative 0.1635, so 164. What does that mean? That means the amount of grass clippings is decreasing because it's negative at the rate of 0.164 pounds per day on day 15. So the amount is decreasing at the rate of negative 0.164 pounds per day at day 15. So the rate at which it is decreasing is actually different each day because of the function. Okay. All right. Part C, find the time t for which the amount of grass clipping in the bin is equal to the average amount of grass clipping in the bin over the interval between 0 to 30. So we want the amount to equal to the average. Well, the amount, we want A of t, that's the amount now, equal to the average. So the average amount is 1 over 30 integral, because that's the rate at which that happens, right? So average of the rate that we have the grass, all right? And it's between 0 to 30, okay? So we have the amount that is remaining, right? So 6.687 times 0.931 to t power. And then that's 1 over 30. Using my math 9, we're going to find the integral. We're going to find the function, 6.687 parentheses 0.931 to the t power, comma x, comma 0, comma 30. And my amount, the average amount, is going to be 1 over 30 times 82.579. So I'm just going to go ahead and divide by 30. That gives me 2.753. So 2.753 is equal to this equation, 6.687 times 0.931 to the t power. So the rest of this is algebra. We're solving for t. When is the amount in the bin equaling to the average amount that you have? So you divide over, so 0.931 to the t equals 2.753 over 6.687. Take the natural log of both sides or log up to you to bring the t down. So t natural log of 0.931 equals natural log of 2.753 over 6.687. To save myself time, I'm just going to divide this over. So t is equal to this natural log divided by that natural log, right? So we're going to take our calculator and go natural log of 2.753 divided by 6.687. Now divide by natural log of 0.931. And we get 12.413. So at around 12 days, right? You will have your average equaling to the amount. You will have the amount equaling to the average. Sorry, the other way around. Okay, so for t is greater than 30, the L of t, the linear approximation, which is the tangent line to A at t equals 30, is a better model for the amount of grass clippings remaining in the bin. Use this L of t to predict the time at which there will be half a pound of grass clippings remaining in the bin. Show the work that leads to your answer. So first thing we want to do is find our L of t, our linear approximation, which again is your tangent line, right? So at t equals 30. What do we need with t equals 30? We need the y value, we need the slope. So a prime of t, a prime of 30 is our slope, right? And we have our equation from up here. We plugged in 15, so that's not helpful. Okay, so let's see, 6.687, natural log of 0.931, close parentheses, 0.931 to the 30th power. Okay, that gives me my slope is negative 0.055976. Remember, because we're using this in the equation, so it's better. It's not a bad idea to keep as many decimals as possible, but it's, you know, again, it's really up to you. Okay, and then we need a of 30. So a of 30, that's my y value. So a of 30, which we got from part A here, is 0.783. Okay, so then my equation is going to be y minus y1 equals m 5, too many numbers, so 0.056. Okay, and x minus 30, 30 is my x value. Clean this up, I get L of t equals negative 0.056x, and then what's 30 times that? So 30 times 0.056, that's going to be a positive 1.68. I'm going to add this over 0.783, so that's plus 2.463. That's our linear approximation, okay? And now we're gonna, when are we gonna have 0.5 pounds of grass left? So 0.5 is what I want. I wanna know when this happens. So set that equal to my linear approximation, 0.056x plus 2.463, all right? So using our calculator, we can work backwards. 0.5, subtract 2.463, and then divide it by negative 0.056. When will this happen? This will be at around 35.53 or 0.54 days. So at around 35 days. So that's why this is very good after t equals 30, because it's after 30 days. Okay, that's it.